we are going to practice graphing a quadratic function that is written in vertex form. So if you don't recall, vertex form of a quadratic function is f of x equals a times x minus h squared plus k. And it's called vertex form because the vertex of our parabola, so that would be our lowest point if it opens upwards, or the highest point if it opens downwards, our vertex is given by the point h, comma, k. And h is in our equation. Notice that it's minus h in the equation, so the sign changes when you write it as a point, and then plus k, the sign stays the same. So if we want to graph our function, f of x equals 2 times x minus 3 squared plus 4, we start by identifying the vertex. And the vertex is x minus 3, so 3 comes right here. And then we have plus 4. So our vertex is the point 3, 4. Now it's helpful to create a table of values on either side of our vertex. So right in the middle, I'm going to put the point 3, 4, and then I'm going to have 2 and 1, and 4 and 5. 2 points on either side is usually enough to get a really clearly defined shape for our parabola. And now we're going to plug in the values. So we have 2 times 1 minus 3 squared plus 4. So 1 minus 3 is negative 2. Negative 2 squared is 4. 2 times 4 is 8. And 8 plus 4 is 12. And then we'll do the same with 2. So we have 2. In fact, this is a really good opportunity while I work this out to pause the video, practice evaluating this yourself, and then check your work in a moment when you get back. That's 2 minus 3 squared plus 4. So that's 2 times negative 1 squared plus 4. So this is just 1. So it's 2 plus 4 equals 6. And there's a really nice thing about quadratic functions in that they're symmetric around our vertex. And so we could call this our axis of symmetry, which means if we go 1 before 3 and 1 after 3, those will have the same y coordinates. So if we plug in 2 or 4, we'll get 6. If we plug in 1 or 5, we'll get 12. So now that we have our table complete, we can draw a graph. So notice that I only have positive numbers here. So I'm only going to draw the first quadrant. I'm going to go 1, 2, 3, 4, 5. And then I need to get up to 12. So I'm going to count by 4s. So 4, 8, 12. And so that would be 2, 6, and 10. So now I can plot each of my points. At 1, I come all the way up to 12. At 2, I come to 6. At 3, I come up to 4. And at 4, I come back up to 6. And then at 5, back up to 12. And you can already see that parabolic shape starting to form. So all I have to do is draw in the parabola itself. Now, before we go, I want to specify one important thing, or two important things really. First, this vertex, because it's at the bottom of the smile, we call a minimum. So a smile has a minimum because that's the lowest point. I'm going to erase our table real quick. If instead I had a frown, this vertex would be called a maximum. And we can determine fairly easily whether or not our quadratic function has a maximum or minimum by looking at the value for a. So notice that when a is positive, we got a smile. When you're feeling positive, you smile. But if a were negative, if you're feeling negative or feeling down, you frown. So looking at the sign of our first coefficient will help us determine whether or not our parabola is going to open upwards or downwards. The second thing I want to point out is that if we look at the first graph we did of the function 2 times x minus 3 squared plus 4, notice that it doesn't intersect the x-axis. This means our quadratic function has imaginary zeros. So if the zeros are imaginary, our graph has no x-intercepts. In our next example, we'll look at how to graph a quadratic function that's written in general form, as opposed to a quadratic function written in vertex form.